Hey there, I'm Alan Furstenberg.
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. How's it going, Mark?
Doing fine. We're back.
We are back. We are in the groove.
Continuing to talk about voice and AI and whatever else we think of to talk about.
That's, vaguely on topic.
Yes.
But I think this week, we've talked about some stuff recently, you and I,
Yeah.
that I think, fits into all of the topics that we commonly talk about. So, and I'm looking forward to some of the other conversations that we've discussed, but I think tonight we want to talk about something that is very, very near and dear to my heart.
Something you've been spending a few hours,
I've been
a few dozen hours, a few hundred hours? I don't know.
Not quite a few hundred. At least not on this particular piece.
Okay.
Some of them I'll be talking about another time. But this one, as we've talked about in the past, I've been contributing to the LangChain JS project.
Yes, you have.
Adding new classes, new modules, new stuff for LangChain JS. And I feel like I want to emphasize the biggest reason why I'm doing so is because we're seeing a lot of, all of these AI tools that are out there. Many of them are getting APIs, which is great.
Right.
But many of those APIs are still kind of shrouded in mystique. Python developers get a lot of access, and people talk about, Python developers having access. But I really feel like everyone should have access to this stuff.
Yes.
And when LangChain JS came along, it started providing that way to bring a lot of the new cool tools that had been, started in the Python version to the JavaScript world. And I wanted to contribute by bringing a lot of the Google APIs into LangChain JS. So that's a lot of what I've been doing. And last week, they announced that there was a new model that was available from Google in public preview at the time called image embedding. And I dove on it to get it implemented in LangChain JS.
Right.
So there is now a LangChain JS version of it in an experimental subdirectory. It's listed as experimental because we're breaking some of the rules of LangChain to do this.
Oh, interesting. This will be fun to talk about. But thank you for contributing to open source. Continue to support LangChain JS, and for those out there that also contribute to open source, a shout out to you for contributing and helping out the open source community, so other developers can learn from your experience and partake of the work that you and others are doing.
No, I think it's important.
Yeah.
I think this is the sort of toolkit and the sort of tools and the sort of documentation that I hope will come with it that benefits everybody. That brings these things it makes these things available to a wide audience, and I think that's important.
Well, let's take a step back, and can we just kind of remind everybody that maybe that hasn't jumped in, what are embeddings, what are text embeddings, kind of how does this play a big role in AI?
One of the things that's not really talked about a lot, I feel like, in this whole large language model revolution that's going on, are these things called embeddings. And with text embeddings, what you do is, and we've talked about this a few times on the show so far, because obviously we think it's really important.
Yeah.
You're basically, with a text embedding, you're handing it a chunk of text, and it's returning a bunch of numbers between -1 and 1 in most cases. And these are known as embeddings. Exactly what these, or sometimes it's referred to as an embeddings vector or a vector of numbers. It's an array of numbers. We don't really know what these numbers mean. We don't know why something would have 0.75 in one field and a 0.3 in another, while something else that we enter in would have different values there. But that's kind of what the magic of the LLMs have done, is basically transform this text that we've given into a series of numbers that kind of represents what we wrote semantically.
So that's an important point. So on AI, so if you've got an embedding model, let's call it embedding model A, and you pass in a text string and get back a vector or embedding back for that. If you were to do that same thing with the embedding model B with the same text, you would not necessarily get back the same embedding.
No.
So it's important to note that there are different embedding models, even for text, that come back with different numbers. It comes back with different, a number of numbers for a specific segment of text. So that's going to be important later on when you try to use that in something like a semantic search, which is basically saying if I look up in this whole world of text that I've got embeddings for, I can find things like if I say hot dog, it might find hamburger, it might find ketchup, it might find things that are related, more closely related to that word, as opposed to things that aren't. Now, you don't necessarily know why semantically they seem to be related to each other. It all comes back from the data that was used to create the embedding model that was then used to create the embeddings.
Correct. And, we could go into how to create your own embeddings. I mean, because there are certainly applications where you would want to create your own, set of embeddings for text based on your specific categories and your specific needs. And there are, the embedding model has been around for longer than we think of these LLMs. They've been around for several years now. One common thing to do, and it was common, it's gotten even more common, is to do things like take chunks of text, get the embeddings for them, and save them in a vector database.
Right.
Which is really more like a vector index. The term vector database is a poor term.
You're not doing SQL queries against it.
And then later you go in, and if you have a query or a question or something that you want to match, you would embed that to get the embeddings, getting that vector and find where that vector has nearby neighbors, or what's known as a k-nearby neighbor algorithm. And there are a variety of algorithms to do this, and there are vector databases that do this for you. But what they've shown is that they work remarkably well to get you things that are semantically similar to what you are talking about or asking about or so forth. So these days you're seeing a lot of people saying things like, create your own ChatGPT based on your own documents. And what those are all doing, fundamentally under the covers, is what they're all doing is they're taking your documents, breaking them up into chunks of text, getting the embedding for that chunk of text, storing in a database so that when you talk about something, it turns that into an embedding, goes look in the chunk of text, finds something that was relevant there, and comes back and repeats that back to you.
So with LLMs and generative text and AI, they make use of embeddings, but like you say, embeddings can stand on their own. They're a very powerful concept in and of themselves. You could use vectors and embeddings and vector databases without having generative text at all.
Absolutely. One of the things that was very common for a while were to use these for recommendation engines. Netflix being a prime example for this, where they've broken all of their movies down into thousands of categories. And each movie is rated, based on how much it fits into that category. Not just, is it horror? Is it science fiction? But is it science fiction with a spaceship? Is it science fiction with androids? Is it science fiction on a future Earth? Is it science fiction on another planet? Breaking it down into thousands, is it a Western? Is it a spaghetti Western? Is it a Western from the 40s, from the 50s? All of these sorts of things. So that when you indicate that you like a movie, it gets the embedding for that movie, looks at what other movies are near that one in vector space, and says, oh, because you liked this movie, you may also like these other movies.
Right.
So these were very, very common things to do long before LLMs came along to do them. The only advantage that LLMs have done is, instead of us having to manually determine those thousands of categories and manually figure out which movies go into which category, the LLMs have determined the categories on their own, and they sort everything into them and weight how everything fits into those categories. The downside is we have no idea what those categories are. We, as people who are using it, I kind of hope the ML engineers know what those categories are, but I don't know.
Yeah, and part of it is they just throw so much input data at it to generate these models that it's just, it's just kind of, it's approaching what is known to a certain extent. It doesn't know everything, but what is known on the internet, or what is known in certain categories. It could be medical, it could be other, other areas where you might have specialized LLMs that's trained on certain data, that it just starts to kind of groks. It kind of understands the general, right, where things are, and it makes all these numbers up. So then you can find close relationships just by knowing a vector of something.
Exactly. So that's the background of vectors and embeddings and text embedding specifically.
Well, so now I'm interested, because I just wanted to make sure that we're everybody was on the same page, and I understand very well. Well, I guess as well as I know what the time that I've spent this year, a lot better than I did, I guess. I know how text embeddings kind of work, or at least I have a mental model on how it makes sense to me, and how it can be used. But now you're talking about a different type of vector embedding and an image embedding, and now my mind's just going to go boom. What does that mean? How does that even work, or what is it even semantically similar to? Or
I don't know, and that's part of it. Is I'm the same way. Is I can sort of wrap my head around the fact that we're going to have two images that are semantically similar to each other, or visually similar to each other, or something. I don't know.
Is it taking just the image of it, or is it like saying this image contains a dog, a cat, and outdoors?
I think it's more than that. One of the things that we've been wondering for a little bit now, because recently Bard started introducing uploading an image and being able to ask questions about that image, and it's using some of this technology in it behind the scenes. I'm pretty sure of that. And we've seen Google Photos over the years have had things like, similar images, or, that it will pull out on its own, that are using technology like this. But we don't know the exact method. And I've just started to experiment with this sort of thing myself, trying to not exactly reverse engineer it, but get a better handle on what it means and how it does it. So for example, if I have and this is one of my tests, for example, is I have a picture of the shelving unit behind me, and of a couple of shelves on it. And if I take one thing away from that, are they semantically similar? How well does it identify that the two of them, that they were looking at the same thing? Mm-hmm. And it does a pretty good job at telling me that these two pictures are related to each other. I don't know, for example, if I did something like, if I showed it a picture of a Monet painting, or two different Monet paintings, that it would tell me they are more similar than a Monet and a Degas, or, right, comparing two artists from totally different genres. Would they how well would they be similar, and how would that compare to the picture of my shelves? I don't know. These are things that I'm still experimenting with. What I'm reasonably sure of, however, is that the embeddings are not doing something like converting this to an image description and embedding that description. I'm reasonably sure it's not doing that, but I'm not positive. but I'm pretty sure.
So this is interesting. We kind of get, it brings up a point, or at least something that just occurred to me, is that sometimes we may not know all, how things work under the cover, but can we learn enough to still have it be useful to us in certain situations?
I definitely think so in this case. This is a case where if you were trying to do this fuzzy AI comparison, then definitely this is a very powerful tool for you, because you'll be able to do things like submit two pictures and say, are these pictures, how similar are these pictures? Or have a bunch of pictures in a database. For example, if you wanted to do, this was a use case that I've talked about frequently with some members of on my office hours and in Voice Lunch. If you've got pictures of a bunch of different products, for example, cans of products or produce or whatever, could you use this technology to look at something and ask what it is, or ask if this is what you want? And the answer might, if you were, for example, visually impaired and you couldn't see it very well, could this be used to help you identify things? And the answer is maybe. It's certainly one tool that you can use.
Right.
One of the other features of this, and this one is going to blow your mind because it keeps blowing my mind every time I think about it, is that not only can you submit two pictures and say, how closely do these match? Or submit a picture, get a vector, and search in a vector database of other pictures to say what's similar to this one. But you can also submit text, and it will give you an embedding in the same embedding space as the pictures.
Interesting. So it seems like at least some of the data that's being trained on is a description of what is in the picture.
Maybe. I don't know. And that's part of what's confusing to me. And again, part of what I've been testing. But if you use Google Photos, for example, if you've got, tons of photos, you can ask it for things like location. And that's an easy one because that's a tag, and that, it knows that. But you can also say things like trees, and it will show you some of your best photos with trees in them. Or you could say bicycle, and it will show you a picture, pictures that you took that have bicycles in them. And you didn't tag those trees or bicycle. Maybe Google tagged them when you loaded them with trees or bicycle, but how do you add to, do you go through the whole set of pictures and add tags later if you need to? Or do you just rely on the kind of automatic tagging that comes with image embedding, and the text that you use maps to the same space? And it's been interesting. The experiments I've done so far with it show that single word queries like that don't do a great job, but they do a good enough job. So for example, with the picture of my shelf, I asked it for shelf, and shelf, the text word shelf, matched all of the pictures that I had with a cosine distance of 0.01, 0.02, 0.03, which is really low. But when talking about the shelf itself, for the picture of the shelf itself, it gave me a cosine distance of 0.1, 0.11, which is still really low. These cosine distances go up to 1.
Yeah.
But it was much higher than anything else, than any of the other pictures. It was a noticeable difference.
Yeah.
And I've done a chart showing the distance between some of the text ones and some of the image ones, and how they match to each other to try to get a comparison. And I'll have it shown up on the screen when we actually do this. And you can see that some of the text descriptions kind of jump out for the images that they match against.
Interesting.
It's
go ahead. Keep going.
No. Go.
I'm just, do you have an idea? I guess, could you iterate, three uses that you could see, like an application that would use image embeddings to do. You've kind of alluded to like finding photos either by text in the photos or by similarity of an existing photo. But what types of applications might want to use this this capability?
No, that's a great question. There's an XKCD cartoon from a number of years back that boiled down to a manager talking to a developer saying, we need you to take photos from the internet and identify if they're within, if they were taken in a national park. And the developer goes, that's easy, check the tags for geofenced locations. And he goes, and then identify what type of bird it is. And she goes, for that, I'm going to need 5 years in a research team. Well, you don't need 5 years in a research team anymore. If you have pictures of that bird already, you can now take a picture and say, which other pictures does this match? And have a reasonable guess about which birds you're now matching against. And you can do the same, it's very common these days to do things like plant identification. There are a bunch of plant identification apps. And before now, you needed to train models on many pictures of many plants. Now you just need the pictures of the plants. You need to store them in a database and you do a search for it based on a picture. It literally reduces having to know a lot about training models to collecting the pictures, storing them in a database, and calling an API. And that's why this is so powerful in my mind, is because now almost anything that you want to do with images and identifying images, you have an API that does that. And in some ways, that's a little scary. That now means, I don't know how well this works on facial features, for example.
Right.
If I show it a picture of me and I show it a picture of you, how closely are we going to match? I don't know. That's something I need to test.
Yeah. I'll have to take my cap off, or you'll have to get a cap.
Well, I don't know. Well, that's part of what we'll see, is whether it can whether it can distinguish that well enough.
True.
So it's questions, it's things like that now become possible. But also, like I said, this is one crucial part of if you wanted to build Google Photos around your own photos without having to store them in Google. You could, store them wherever you want, store them on your machine, create a vector database on your machine if you want. You'd need to use this to create the embedding for all of them. But once you do, you're now just using embeddings to search for a picture that you may have. So this is a way that you can see if you've got a different size version of the same picture. Or to search your own machine for pictures of birds or trees or whatever. So you don't have to store them somewhere else. So there's 2 applications that we've come up with so far. Third one. Well, I think the third one is, again, it can be the same sort of thing for helping people who have visual impairments figure out what they're holding. Because, you can hold up a can to Google Glass and say, what is this? And it can get the embedding of that, then search its database for, a similar enough image, and which you have tagged what it actually is, and say, well, it really looks like it's a Coke can, or whatever else image matches close enough, or say, it's not a very good match, but it might be this. Try turning the can. That's
also just, you talked about specifically the Google Glass, but I know with Alexa, if you've got a smart display, then, and that's one of the advantages of having a smart display, especially if you're visually impaired, you can hold up something to the camera and ask what it is, and it will tell you what it is, which I'm sure behind the scenes is using some sort of similar technology to image embeddings and vector databases and all that stuff, which gives you an indication that this stuff has been around for a while.
Yes.
It's just that, like so many things, when LLMs came out, they got a lot of attention and they started showing a really bright spotlight on LLMs and the things that LLMs use to be able to do what they do. And one of those things that got the light shined on it was embeddings, and text embeddings specifically that we talked about, and now image embeddings.
And those are really just a few of the things that I thought of. I could easily see that this just becomes, it's just background technology now, that you can say, oh, I've got an image and I need to do this. Oh, there's a library for it. It's just there.
Another API, another tool that you can use when you're creating applications, whether they're mobile, web, desktop, and when you're trying to solve problems, either for consumers or business or whatnot, you've got additional tools and abilities that you didn't have as easy access to before.
Right. And I think the important bit on this is that you're not going against some public set of data. So, you know, with Amazon, with this feature with Amazon, you know, no, we don't have access to the camera. But if we did, all that we'd have access to would be whatever Amazon had stored in its image database.
Right.
If I have a bunch of private or proprietary images or personal images, or I had access, for example, to Shutterstock's images that I had indexed, or I had access to, you know, if I was a news organization and I've had tons and tons of my own images, and I'm just like, oh, we had this image that we took from, it was London or Berlin or something like that, and it was a person waving a flag. You know, how are you going to find that? Now you can just find it because it's your photos. You've indexed them. You can search for them.
Yeah.
You know, those are, I'm really, I mean, part of why I'm excited about this is I want to see what people do with it.
Yeah.
Because I think, well, I want to see the good things that people do with it. I worry about the other things that people could do with it, but I really want to see the good things that people can do with it.
Well, and it's with large language models, there are some kind of guardrails that get put in place, and it's a model. I'm wondering if on some of these other like embedding models that there are some guardrails added as well.
Quite possibly.
To you know, even though we're exposed to something, we may not know how close to the metal we are as far as what we say or input in, or, you know, pass as input to get the output. There might be a number of guardrails or protective layers that get added, so that what we get back, hopefully to try to limit it being used for, you know,
more nefarious purposes.
Yeah. Yeah.
Well, and I think that's a good point. Google does have what they call their list of AI safety guidelines that they adhere to. And like I said, I have not tested it, but it certainly should be something that I test to find out, does it, how well does it handle facial recognition? I would hope that it does not, to be perfectly honest.
Yeah.
Or at the very least that it does so in incredibly crude ways. You know, yes, there's a person in the image. Yeah. If that's the extent of it, good. Beyond that, you know, it's going to take some testing and experimenting to figure out.
Yeah. Well, and I think it's interesting about, you know, kind of your approach. You've taken a picture of a book, a shelf on your bookcase. What if you reshuffled the books, the same books on the same shelf, but in a different order?
That's a good one. I'll have to try that now.
That was like the first thing I thought of, was like, what if you shuffled the books, the exact same books? How close is the embedding?
Well, in my first experiment, what I did was, it's of the shelves behind, some of the shelves behind me, you can see the yellow box that's there.
Yep.
It was a picture of a couple of shelves, including that box, and then I took the box away and I shot the same picture. So it's almost identical, except one is missing the box.
Okay.
And it indicates that the cosine similarity between those two pictures is 0.96, which is saying this looks pretty close to the same, but not exactly.
Yeah.
And again, I don't know on exactly what criteria it's judging that. And then I have a picture of me standing in front of the shelves that I took, what I call my shelfie. And
I like that.
it matches to those two shelf pictures with 0.68 and 0.71. So again, it's kind of saying these sort of, there's similarities here, but not great similarities. So now I need to try, other selfies of me in other situations to see how closely does it match me. And then pictures of other people with their permission and see, do those match me anywhere? It's an interesting experiment. I think mostly it is, and part of the reason I'm doing the experiment is to get a better sense of what will work and what won't with it. When we do text queries, what are good rules to do those, to do that matching? Does it mean that if we give longer, better descriptions of what we're looking for, that it has a better chance of matching? Does it mean that even low similarities, as long as it's higher than other similarity matches, are okay? And that seems to be what I'm seeing so far.
Yeah.
But, for example, the phrase shelf matched the shelf pictures matched the shelf pictures at 0.10. It matched the shelfie at 0.05. And all of my other pictures, it matched below that. Okay, that's not great.
Yeah.
But if with a text prompt of something like books and mugs on a bookshelf, which describes my bookshelf better, it matched the shelf pictures at 0.16. From 0.16 to 0.19, which is really good that's the best result I got. And my shelfie at 0.8. So it was worse on the shelfie.
Yeah.
Because it acknowledged I don't know why, but there was something else in the picture. So, I don't know.
All right, so I've got a question with LangChain JS. So this work that you did is available now?
It is available now. It is available only in the JavaScript library. It's not in the Python library, which I believe is a first for the LangChain project.
Wow.
It is in a module that is listed as experimental. And the reason it's listed as experimental is up until now, all of the embedding models assumed text.
Oh.
And there's a lot of structure around LangChain that assumes that all we're working with is text. So to do this, I just added some new methods. I didn't try to change the old LangChain embedding class model. That's still there. So if you want to embed an image, there's a slightly different function call that you need to make on this class. We are talking about ways to change LangChain JS and LangChain Python so that instead of documents, which is one of the core elements of LangChain, really.
Yeah.
Instead of them assuming that it is text, make it so that these documents could be multimodal.
Okay.
And when they are, there will be questions about how do you get an embedding from a multimodal document? What does that mean?
Yeah.
How do we do that? And because in some cases it's going to make sense, and in some cases it's not going to make sense. How do we, so it's a big question that's going to break a lot of things.
Wow. So not only did you get it out there quick in JavaScript first, but kind of breaking some things maybe, or at least pushing the boundaries to figure out what it could look like.
Well, that's it, is that we're not breaking anything because which is why it's an experimental. We're not breaking anything because that was way too much to do.
Yeah.
But we did want to get it out there to use with other LangChain tools, because LangChain offers great ways to work with vector databases. So this is now a great way that you'll be able to turn an image into a vector database, or get it into the vector database, and then use text queries using all of the other LangChain support features that we have for doing text to embeddings, and get information back out.
Okay.
And that, I think, I don't know, I keep going on and on about this. I think that's really cool.
It is really cool. That's it's fun when you're excited about something and you're moving and along on it, but it's also fun when you can see it make its way into some sort of ecosystem, in this case LangChain JS, and even where it's like, oh, this is new, let's kind of figure out how this is going to, and we've seen this quite a bit with LangChain, over the last year, just like, oh, this is a change, we're going to kind of refactor this part of it and split out retrievers, we're going to split out this thing, we're going to
we're going to come up with this concept of agents, and then we're going to see OpenAI adopted as a core feature. We've seen these sorts of things happen over and over. And that's one of the things that's great about open source, is that if somebody has an idea, they can do it, they can contribute it, we can see things change.
Well, it seems like you probably worked closely with at least a few, one or two people on kind of exploring how what this change might look like, and kind of making sure that it was fitting in within the.
That's one of the great things about the LangChain team, is that they have stewards for each project who have that big sense of what's going on.
Yeah.
And when people are contributing, and there are lots of people who are eager to contribute, and that's great to see, help steer them to make sure they're doing it in a way that's more or less consistent with how everything else is going.
Yeah.
We did have questions about, well, okay, what do we do with this? Since it is going outside the model, what's the right way to go outside the model?
Yeah.
And we didn't have a good answer yet. So until we have a better answer, this is the best way that we have.
Well, that's really cool. I encourage people to go out and check out LangChain JS just in general. LangChain if you're a Python developer, but start looking around at this new Google-based image embeddings, and start thinking about how you might be able to use that in a project, whether it be something at work or something for fun for what you're doing, something very serious. It could be a game. I don't know, whatever you.
I know there are so many. I mean, I want to see how people use it, and when you do, I really hope you reach out to us. You post on social, talk in the comments, or find us on LinkedIn and talk about what you've done. Share with us what you're doing with these cool features or with other stuff, because we want to talk about it. We want to explore what this is doing. We've seen a lot of people get really excited about this feature already. I'm really excited to see when we start seeing outputs of it. And we will talk about this more on another Two Voice Devs.
Two Voice Devs. Take care, Alan.
Take care, Mark. Have a great week.
You too. Thank you.